Epigenetic effects of a ketogenic diet. Most of us think of a ketogenic diet as a method of shedding fat and pounds, something it is well proven to be good at. However, the health benefits of a high-protein/low-carb diet go far beyond weight loss. In fact, when the ketogenic diet was first developed in the 1920s, its original purpose was for the treatment of epilepsy, something for which it is still recommended today. And the benefits don't stop there either. Emerging research that suggests that a ketogenic diet may facilitate some positive epigenetic changes. Epigenetics is the study of DNA-independent heritable phenotype changes. That's a lot of syllables to say that epigenetics is about changes in the way cells interact with other cells without altering their genetic makeup. This is great news for those who worry that their genes doom them to physical ailments or a short life. In reality, our diets can affect our gene expression without altering the genes themselves. Back in May, we discussed ketogenic diets and compared them to low-fat diets to help you lose weight. And we even provided meal plans for a great ketogenic diet in our June article, Keto Diet Meal Plan. In this video, we discussed the basics of epigenetics and the potential of a ketogenic diet to work in your favor. How keto diet impacts your epigenetics. Understanding epigenetics. To understand epigenetics, we must look at how cells communicate and behave. Histones are proteins that bind DNA in a coil known as chromatin. Genes communicate through the gaps in the coil, gaps that are open when the chromatin is bound by. Histones have an acetyl grouping attached rather than a methyl grouping, which creates small, tight chromatins. Gene expression is made even more difficult when HDAC, histone deacetylases, enzymes remove acetyl groups, and DNA methyltransferase enzymes add methyl groups. Both of these enzymes tighten chromatins and inhibit gene expression. What is a ketogenic diet? And here is the good news for those readers barely hanging on through the chemistry talk. A ketogenic diet includes specific compounds known to inhibit HDAC, making those coils looser, the gaps bigger, and gene communication and expression better and more prolific. For example, from the ketogenic diet staples butter and cheese, your body will get plenty of butyrate, an HDAC inhibitor. And many of the keto-allowed vegetables, cabbage, broccoli, cauliflower, kale, Brussels sprouts, you can stock your system with sulforaphane, another HDAC inhibitor. Studies on epigenetics and keto diet. In their 2018 study, Ruan and Crawford summarized conclusively that direct regulation of gene expression may occur in vivo through ketone body-mediated histone modifications during adherence to low-carbohydrate diets, fasting ketosis, exogenous ketone body therapy, and diabetic ketoacidosis. Also in 2018, Drs. Scott J. Koppel and Russell H. Swerdlow teamed to conduct and publish research that concluded that keto therapeutics enhance mitochondrial respiration, promote neuronal long-term potentiation, increase BDNF expression, increase GPR signaling, attenuate oxidative stress, reduce inflammation, and alter protein post-translational modifications via lysine acetylation and beta-hydroxybutyrylation. And even more recently, in June 2020, Bandera-Merchan, et al. Gave a published review and noted that multiple studies have shown increased survival in cancer patients, reduced side effects of cytotoxic treatments, and heightened efficacy of cancer treatments. If you like the video, give it a thumbs up and share it with your friends. If you want more tips, subscribe to the channel.